Now let's look at a couple of problems where we have to use our exponent rules, but instead of the exponents being nice integers, now the exponents are fractions. So we're going to look at some problems, exponent rules, when we have rational exponents. So here's the first problem we'll look at. 8r in parentheses raised to the 1/3 power times 2r to the 1/2. Now one of the key things I want you to realize first is the difference between these two factors here. You notice here the 8r are both inside the parenthesis. So that means we'll use the power rule. The 1/3 gets applied to both the factors inside. But if you look at the second parenthesis, you notice the 1/2 is on the inside of the parenthesis, and therefore the exponent of 1/2 only gets applied to the r. The 2 is just there being multiplied. So if I apply the power rule here to that first parenthesis, I'm going to have 8 to the 1/3 r to the 1/3 times 2r to the 1/2. So now I notice I have two factors of r here, r to the 1/3 times r to the 1/2. In a minute, we're going to apply the product rule to these two to combine these. But then I also have two, what I would call numbers, the 2 for sure, and then this 8 to the 1/3 power. I also want to combine those, but before I can do that, I need to figure out what 8 to the 1/3 is. So let's just go down here and think about that for a minute. Once again, until you become familiar with these rational exponents, usually the easiest thing to do is to convert this into a radical. So here's my radical sign. There's my base. My denominator is 3, so my root is 3. The numerator is 1. I can either put the 1 on the inside or the outside, but either way it doesn't matter. I don't even need to write the 1 there. So 8 to the 1/3 is the cube root of 8, which we know is 2. Now at the same time, let's go see what happens with r to the 1/3 times r to the 1/2. The product rule says when you multiply two exponents with the same base, you add the exponents. So r to the 1/3 times r to the 1/2 is going to be r to the 1/3 plus 1/2. Well, in this case, I'm actually adding two fractions, and as it turns out, they do not have the same denominator. So I'm going to go down here and first try and add these two fractions, because when I add these two fractions, that is now going to be the exponent of my r variable. So 1/3 plus 1/2, hopefully you all remember that when you add or subtract fractions, you have to have a common denominator. So in this case, if I look at 3 and 2, the lowest common denominator is going to be 6. So to convert this to my common denominator, the first fraction I multiply by 2 over 2, so I get 2 over 6. The second fraction multiply by 3 over 3. And I have 3/6. So now 2/6 plus 3/6, you add the numerators and write it over the common denominator, and it's 5/6. So now if I go back up here, 8 to the 1/3 is 2. Well, let's just save a step. 8 to the 1/3 is 2 times 2 is 4. R to the to the 1/3 times r to the 1/2 is r to the 5/6. All right, so the key is we're still applying the exponent rules we've already been using, except now we have some rational exponents. Let's look at another quick example. How about if we have this? Negative 8x cubed over y to the minus 6, and that whole thing raised to a power of 2/3. Well, inside the parentheses I have three factors. Negative 8, x cubed, y to the minus 6. The power rule says the 2/3 gets applied to all the factors inside. So negative 8 to the 2/3 times x cubed raised to the 2/3 power all over y to the minus 6 raised to the 2/3 power. All right, let's figure out what's going to happen now with this minus 8 raised to the 2/3 power. I'm going to once again convert this into a radical. And just to be clear, I need to put the parentheses in here. I would convert this into a radical, and then we can figure out what number it equals. So minus 8 goes under the radical. I look at my exponent. 3 is in the denominator, so 3 is going to be my root. My exponent's 2. I always like to do root first, so I always put the numerator exponent way on the outside. So this says the cube root of minus 8 is just minus 2, and now we square it, so it turns out it's 4. So negative 8 to the 2/3 is 4. Now if I look here, x cubed raised to the 2/3 power. If you remember, the power rule says you multiply these two exponents. And just in case some of you are a little rusty on doing math with fractions, there's really two ways. Students usually like to multiply a number times a fraction. One way is just you can multiply the number times the numerator and then divide it by the denominator. So that'd be 3 times 2, which is 6, over 3, which is 2. Now other people, notice that you got a 3 here and a 3 down here in the denominator, so other people realize they just cancel out and you're left with the 2. Either way you want to do it, it's going to be 2. So therefore, we end up having x squared, and now if I go to the denominator, y to the minus 6 times 2/3. If I just multiply it out, minus 6 times 2 is minus 12. Minus 12 divided by 3 is negative 4. So I'd have y to the negative 4 in the denominator, which of course we cannot leave a negative exponent. So if I make the negative 4 positive, it comes up into the top as y to the 4th. So the final answer is 4x squared y to the 4th. Now let me do one more just quickly. because this is sort of like what you're going to see on the homework. So x to the 6th over 9y to the minus 4, all raised to the negative 1/2. Once again, hopefully by now you're starting to get the hang of this. We have 3 factors inside. I'm going to go ahead and apply the negative 1/2 rational exponent to all the factors inside. X to the 6th raised to the negative 1/2. That's going to be 6 times negative 1/2. That would be x to the negative 3. 9 to the negative 1/2. And then y to the minus 4 raised to the negative 1/2. You multiply those exponents. And you get y squared. So in a minute, we'll have to take care of this minus 3 for the exponent of x. But for now, let's look at what happens 9 to the negative 1/2. First thing I'm going to do is I'm going to get rid of the negative exponent. So it's going to go down into the denominator as 9 to the 1/2. Now let's figure out what 9 to the 1/2 equals, and then I'll plug it back in as a denominator here. So let's take 9 to the 1/2, and if you don't quite see what that equals yet, we can always convert it to a radical. The root is 2, so it's a square root, so I don't write anything here. The numerator is 1, so basically 9 to the 1/2 is the square root of 9, which equals 3, which means this. So as it turns out, 9 to the negative 1/2 equals 1/3. I'm going to get rid of that negative exponent on the x, so I'm going to go down to the bottom. So I'm going to have x cubed, 9 to the negative 1/2, I said ends up being 1/3. And then here's the y squared. Now here's another rule in math. You never want to leave a fraction in the denominator. And the quick rule of thumb is, when you have a fraction in the denominator, this ends up going to the top, and then the numerator just stays in the bottom. I could prove that to you, but for now, I'll just have you take my word for it. And there we go.